Let's go ahead and solve this initial value problem. First of all, I'm going to rewrite this as dy by dx equals x y squared plus 1. Remember that these two they mean identical things, they're just different notations, and for these kind of problems, this is way more convenient. Okay, so now I'm just gonna, what I try to do is try to get all the terms on two separate sides, right? So we want dy and the y's on one side and the x's and dx's on the other side. So I'm just going to multiply this whole thing by dx, which would bring this up here, and then I'm going to multiply this whole thing again by 1 over this term, which would bring this down here, and that gives me 1 over y squared plus 1 dy dy equals x dx. Okay, now we can go ahead and take the integral of both sides. So the integral of both sides, and it's just worth remembering that the integral of this integral of 1, this is just tan inverse of y, and this is pretty trivial, right? We know how to do this. This is simply just x squared over 2 plus c, and of course there's going to be a plus c as here as well. So finally we can bring both of these together to get the tan inverse of y plus c equals x squared over 2 plus c. Okay, now we can get rid of one of these c's, because basically c plus c is just c, because these are arbitrary constants. They're not actual values. Okay, so now we can just say y. So we can take the tangent of both sides. That would just give us y equals the tangent of x squared over 2 plus c. Okay, now we are given this initial value. So this is basically, well, this is basically just y of x is tan of x squared over 2 plus c, right? So we're given that y of 0 is 0. So if we plug in 0 to this equation, we get y of 0, which is 0, which equals tan 0 over 2 plus c. Okay, and we take tan inverse of, so this just goes to 0, right? So it's just, so if you take tan inverse of both sides, we get 0 equals c. Okay, and then we can plug this back into our equation, which is what we have here, right? And that gives us y equals the tangent of x squared over 2. Okay, that's our answer.